Alrighty, so this video is our math review for trigonometry. Trig, like algebra, is a critical piece of mathematics to know to be able to be successful in physics, to be able to solve problems. You will see why in a future lecture, but just as a preview, it's because almost everything you ever do in physics requires the use of what's called a vector. Vectors allow us to talk about information in a much more efficient way, to give more information, more data with less steps. So, for instance, one example is speed. Speed is what's called a scalar. It's a number. If I ask you how fast you're going, you'd say 35 miles per hour. That's a speed. However, if you gave me a vector version of speed, that would be called your velocity. And a vector version, the velocity, not only tells me how fast you're going, but also tells me what direction you're going in. So you'd say, I'm going 35 miles per hour on Joe Yenny Boulevard heading north. Well, that gives me much more information with the same number of things. One was speed, gave me how fast. The other is a velocity, and it tells me how fast and in what direction. In order to use vectors, we need to be very proficient in trigonometry. Now, not every aspect of trigonometry is necessary. If you remember, when you took trigonometry, it basically dealt with triangles and how to manipulate triangles, or how to use the information given on one triangle to get more information that's unknown, and so forth. We will concentrate to special cases where the triangles are right triangles. So that is to say, when you're given a triangle, one of the angles is 90 degrees. So there's a right triangle. When we specialize to right triangles, and we're looking at a subset of trigonometry, that makes things a lot easier. So what do you need to know to be good with right triangles? Well, the first thing is called the Pythagorean theorem. And what the Pythagorean theorem tells you is it relates the lengths of the sides of a triangle. So, let's say I happen to know that this triangle, the bottom side length is 3 meters, and this top side length is 4 meters. And I say, how long is this side over here? Well, first of all, there's a special name for that side of the triangle. This side, R, is the side which is opposite to the 90-degree angle. Because of that, it must be the longest side of my triangle, because this angle, the 90-degree angle, is the biggest angle of the triangle. So that side has a special name. It's called the hypotenuse. So, what does the Pythagorean theorem say? Well, it says that the sum of the squares of the two sides of the triangle, that is to say this side and this side, must equal the square of the hypotenuse. A lot of times you'll see it written a squared plus b squared equals c squared, where one side is called a, one side is called b, and the hypotenuse is called c. So, for our particular triangle, our example here, if I'm looking for r, I would be told 3 squared plus 4 squared must equal our r squared. Alright, that's not so bad. So let's plug in my number. 3 squared is 9, 4 squared is 16, equals r squared. 9 plus 16 is 25, is r squared. Well, I don't want r squared, I just want r, so I have to take the square root of both sides. So I'm told r must be 5. So I now know the length of my hypotenuse is 5. And that's what the Pythagorean theorem can do for us. If you know 2 out of the 3 sides of a right triangle, you can get the third side using the Pythagorean theorem. In this case, the third side happened to be the hypotenuse. However, what if we have an example where it's not? Let's say I have this triangle here. This is 10, this is 6. Let's call this x. All right, well, now I want to find out what's the length of side x. Well, first of all, I can see this is my right triangle, and that means this 10 side is my hypotenuse. So I know Pythagorean theorem would tell me x squared plus 6 squared must equal 10 squared. Remember, the hypotenuse is on one side, and the other 2 smaller lengths is always on the other side. All right, so we have x squared plus 36 is equal to 100. I want to get the x by itself, so I'm going to move the 36 over to the right. That becomes 100 minus 36, which is 64. Again, I don't want squared, so I take the square root of both sides, and that tells me x must be 8. So I know the length of this side must be 8. So that's the Pythagorean theorem. If you know 2 of the sides, you can get the third side quite easily. What else do we need to know for trigonometry? The next big thing is called SOHCAHTOA. Now, this is how I learned it when I was growing up, and I think most people learn it this way too. But I have seen a friend of mine in college, he was from Honduras, and apparently they didn't teach SOHCAHTOA where he's from. They taught it some other way, and I don't know the other ways. All I know is SOHCAHTOA. But this is basically a little mnemonic, helps you remember relationships about triangles. And so let me draw a little triangle. I'm going to call this angle here, I'll call it theta. Here's my right triangle. Now if this is x, this is y, and this is r, what is SOHCAHTOA telling us? SOHCAHTOA is a way of remembering how do the side lengths relate to the angles inside the triangle. Well, one relationship we already said was that whatever side is opposite to the right angle, that's the special side called the hypotenuse because it's the longest. Well, there are other relationships too. And what these things say, let's take SO for instance, that says that the sine of the angle theta is equal to the side which is opposite to the angle. So the side opposite to the angle is that side over there, y, divided by the hypotenuse, the h, r in this case. So is sine, opposite, and hypotenuse. So the sine, which is just a function in your calculator that you could plug in, and it'll give you a number. But if I take the sine of that angle theta, whatever that number is, it's the same as if I took the length of side y and I divided it by the hypotenuse r. What about ka? Very similar. The ka part says the cosine of my angle theta is equal to the side which is adjacent. That's what the A means. Adjacent to the angle. Well, here's the angle. The side which is adjacent means next to, of course, is this side here, x, divided by h, the hypotenuse, which is r for us. So that says cosine, adjacent, hypotenuse. And then lastly, TOA says the tangent of the angle theta is the side opposite, which for this angle theta, the opposite side is my y, divided by the adjacent, which for that angle is x. So that's what SOHCAHTOA tells me. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, do not remember cosine goes with x and sine goes with y. That's not true. Cosine goes with adjacent, sine goes with opposite. For this example, the opposite side happened to be y. But that's not always true. Sometimes the side adjacent will be y. For instance, take this triangle. Let this be my angle phi. Here's my right triangle. Here's my x. Here's my y. Here's my hypotenuse. If I say, okay, what's sine of phi? Well, sine is opposite over hypotenuse. If I put y over r here, I'm wrong. Because the side which is opposite to my phi is that one there, which is my x. Cosine for this one is y. So you have to be very careful. Remember SOHCAHTOA, sine is opposite over hypotenuse, and then look at the triangle and see which side is opposite. That's the side which goes away from the angle. And which side is the adjacent side? That's the one that's right next to the angle. And of course the third side is the hypotenuse. But if you remember SOHCAHTOA, it's easy to remember these relationships here. Now, why is that important? Well, it could be that you need to know what value is this theta. So let's take an example. Let's say I have this problem here. Let's say this is 3, this is 4, this is phi, this is theta, this is r, and this is my 90-degree angle. The question is, find r, theta, and phi. Okay, well, let's see. How do I do it? First thing I could do is I could find r quite easily using Pythagorean theorem. 3 squared plus 4 squared is r squared. And I did this before. We already know r is equal to 5. So there's one of my answers. How do I find theta? How do I find this angle over here? Well, there's different ways of doing this. I could use sine. If I wanted to use sine of theta, then I'd have to say, okay, sine, that's so sine is opposite. Opposite to theta is the 4 over hypotenuse, which I just found was 5. Okay, well that's fine, but how do I solve this equation for theta? Well, in order to do that, let me just put a little aside here. When you have something that looks like this, 5x equals 10, and I say, okay, I want you to solve for x, what do? Well, what everybody says is, well, you just divide by 5 to get rid of the 5. Do it on the other side, that becomes 2, so you get x is equal to 2. And that's true, but why did you divide by the 5? We had (5x is equal to 10). I wanted to get rid of the 5 because I wanted x by itself. In order to get rid of the 5, I have to do what's called the inverse operation. That cancels out what I'm doing. Because if you think about it, what this is saying is multiply x by 5. But I don't want to do that. So in order to undo that, I do the inverse thing, which is divide by 5. Because dividing by 5, when you multiply by 5, cancels each other out. The same thing is going to be true over here. Here I want theta, but I don't have theta, I have the sine of theta. So I'm doing an operation of taking the sine. So if I don't want to do that, I have to do the inverse operation of taking a sine. What is the inverse of taking a sine? It's called inverse sine. So I take this term and I do what's called the inverse sine of it. And that cancels the sine part. Just like over here, dividing by 5 got rid of the multiplying by 5 aspect. On the left, taking the inverse sine got rid of the sine itself. However, in order to do it to one side, you have to do it to the other as well. So on this side, I also have to take the inverse sine. And so what am I left with? I'm left with theta on the left, because the sine's canceled, equals inverse sine of 4 over 5. Now, unfortunately, this you can't just do by hand. This, you're going to use your calculator. And when you use your calculator to solve for this, you should get 53 degrees. Here's a little tip. Make sure, because we're solving for degrees, your calculator is in degree mode. I know a lot of times in mathematics they want you in radian mode. Here you have to use degrees. We're going to use degrees in physics, so use degree mode. So that's how you can find theta, using the sine. We started with sine of theta is opposite of our hypotenuse. But then we didn't want sine of theta, so we had to do the inverse sine of both sides. That left us with theta equals the inverse sine of 4 over 5. You plug that into your calculator. That gives you 53. Theta is 53 degrees. I now have my theta. Now, before I move on to phi, note I didn't have to use sine. I could have used cosine. If I used cosine instead, I would have had cosine of theta equals, well, cosine, that's the ka, that's adjacent. So the side adjacent to theta is 3 over 5. And the same kind of a thing. In order to get rid of the cosine, I take the inverse cosine. But I also have to do it on the right side as well. Inverse cosine cancels cosine, so I get theta is inverse cosine of 3 over 5. And again, when you plug this in, you get 53. Finally, the third way you could have done it was using the tangent, TOA part. So tangent theta is opposite, which is 4, over adjacent, which is 3. And likewise, theta is inverse tangent of 4 over 3. So you have 3 options. You could use any of them. Personally, I would have used tangent. And the reason I would have used tangent was because if you notice, when we use sine, we had to use the hypotenuse. And when we use cosine, we had to use the hypotenuse. But the original problem didn't tell us what the hypotenuse was. We found out and calculated a hypotenuse. So imagine if when I did this part, I calculated wrongly, and instead of 5, I got 6 for some reason. Then everywhere in the sine or the cosine calculation, I needed to have my 5, I would have had 6 by accident, because I was wrong in a previous calculation. That means all the answers would have been wrong here and here as well. However, in the tangent part, notice I didn't have to use the hypotenuse, because the tangent only needed the opposite and the adjacent, which were already given in the problem. So for me, because I have experience with this stuff, I know that if I have the ability to only use information given in the problem to solve the problem, and not have to use stuff I worked out myself, it's best to do it, to be on the safe side. Because imagine you're at work, you're an engineer, or you're in a lab, and you're having to do a bunch of calculations. Well, imagine you make a little bitty mistake at the beginning of your work, and then you keep using that mistake number over and over for all the rest of your calculations. Everything's going to be wrong. However, if at every opportunity you only use the numbers that were given to you by your boss, then either you're going to be right, or if you're wrong not because you miscalculated, but because the information that was given to you was faulty to begin with. So it's not your fault. Now in this case it didn't matter because I know 5 was correct when I calculated it, and I know I didn't make a mistake, so it's fine. There are going to be times when you don't have the ability to not use something you already calculated. I'm just giving you a little tip for some thought in the future. It's just good practice that if you can solve the problem without having to use your own numbers and only use the numbers that were given to you, there's less likely going to be any errors on your part. But all 3 of these methods work. Sine, cosine, or tangent would have been fine. Now notice there's one more thing we need, which was, if this was 3, this was 4, this was theta, this was phi, this was r, we also wanted to find phi. Now, how can I find phi? I have 2 methods, or actually I guess 4. I could do phi the same way I did theta. So I could say, okay, sine of phi is opposite, which in this case is 3, over hypotenuse, which is 5. Or I could say cosine of phi is adjacent, which is 4 over 5. Or I could say tangent of phi is opposite 3 over adjacent 4. Okay, that's fine, no problem. The other way you could do it is there's one more relationship about triangles you should know, which is the 3 angles in a triangle add up to 180 degrees. So if I want to use this, what do I know? Well, I know one angle is already 90 because it's a right triangle. I also know if I add the other 2, I'm adding theta and I'm adding phi. This better be equal to 180 degrees total. So bring the 90 over to the other side. That says theta plus phi must be 90 degrees. 180 minus 90. Well, I already know theta from before. I just calculated theta. That's 53. So 53 plus phi is 90. So bring 53 to the other side. Phi then must be 90 minus 53, which is 37. And now I know my phi. So there's a different method. Here, of course, you only want to do this if you know for sure theta was correct. But you could also use these methods here. They both work, and whichever method you want to use is fine with me. It doesn't matter. This is basically all the trigonometry you're going to need, for the most part, to solve these problems. You have to be comfortable knowing when do you use sine, when do you use cosine, which side is the opposite side, which side is the adjacent side, things like this. Adjacent, that just means what's the side which is touching your angle, and opposite means what's the side on the opposite side of your angle. So just be careful you don't get into the habit of thinking cosine goes with x and sine goes with y, especially in the future when we're talking about vectors. That can get very confusing. But if you remember SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And you remember Pythagorean theorem, a squared plus b squared equals c squared, where c squared is the hypotenuse, that's the longest side, or the side which is opposite to your 90, then that's pretty much what you need to know for your trig. So if that makes sense. Now, the last thing you're going to need for this, which comes up in the engineering part of things, is the law of sines and a law of cosines. Now these two are needed because in engineering we're not always going to have right triangles. And if we don't have right triangles, SOHCAHTOA and the Pythagorean theorem don't work anymore. So we need some other relationships that do hold for generalized triangles. So we'll start with law of sines first. That's not so bad. It says given some random triangle, okay, let's say this is side A, B, and C. And if so, then let's call this angle alpha, this angle beta, this angle gamma. The law of sines says that the sine of angle alpha divided by the length of alpha's side A, so that is the side opposite to the angle, is the same as the sine of angle beta over the length of side B. And it also happens to be the same as the sine of angle gamma over the length of side C. So this actually stands for a number of different equations. 3, I believe. But what it says is the ratio of the sine of an angle to its opposite side is constant for a triangle. So if I know 3 pieces of the triangle and I need the 4th, I could get it using law of sines. So let's think of an example. Let's say I have this triangle here. Let's let this be 7. This is 44. This is 53. I don't know this. I don't know this. And I don't know this. All right. So, what do I want? I want to find out what is theta, what is x, and what is y. Well, what can I do? First thing I can do is I already know what theta has to be. If you remember, all 3 sides must add up to 180. 180 must be equal to the 53 plus the 44 plus whatever theta is. So that means theta must be 180 minus 53 minus 44, which tells me theta must be 83 degrees. I now know theta. So that's fine. What about x and y? Well, what do I know? Let's say I want to do x. If I want to solve for x using the law of sines, then what I need to know is, first of all, the angle associated with the x. Well, I do. That's 53. Good. What else do I need to know? The other thing I need to know is a full set of information, that is an angle and its side. Do I know an angle and its side? Yes. I have the 7, and the angle with the 7 is the 44. So perfect. I can now use law of sines, which I'll do right here. Law of sines says sine of 53 over his side, which is x, the one I'm looking for, must be equal to the thing I know, sine of 44 over 7. Right? I was looking for x. I need to know x's angle. X's angle is over here. That's the 53. So sine of 53 over x. The other side of the equation is just I need one whole set of information. It doesn't matter which side I'm looking at. Well, the only one I have for sure is the 44 angle, and the side with the 44 is the 7. So there it is, sine 44 over 7. And now all I have to do is solve this equation for x. So if I'm going to solve this, first thing I'm going to do is I'm going to bring the x to the other side, and then I'm going to bring these two, the sine of 44 and the 7, over to the other side as well. So this becomes x equals sine 53 times 7 over sine 44. And when you plug all of this stuff in your calculator, you should get 8.05, I believe. So that's how we use law of sines. One piece of information I don't know, the x, but I do know the other piece, the angle. Then I need to know a whole set. Here's a length 7 and the angle with the 7. Perfect. Now what about y? In order to do y, I need to know the same thing. Say, okay, in order to define y, I need y's angle. Y's angle is theta. Do I know theta? I just calculated it over here. It's 83. So sine 83 over y equals, and now again, I use a full set of information. I may as well use the same set I knew before, sine 44 over 7. And so again, just manipulate this equation, bring y up to the other side, this stuff over, and I get sine 83 times 7 over sine 44 equals y, and that tells me the answer for y is 10. So, once you get the hang of it, law of sines is really easy. And in fact, it could be even easier because you could either do sine of alpha over a equals sine of beta over b, or you could do a over sine of alpha is b over sine of beta. That would have been easier here, since I was looking for the y, and y is in the denominator. I could have flipped things over using this method instead, and it would have been y over sine 83 is 7 over sine 44. And if I did that, then all I had to do was bring this to the other side, one step. But I didn't want to confuse things ahead of time. So there's your law of sines, right here. Very easy thing to do. What about law of cosines? Law of cosines is not quite as straightforward, but it's still doable. Law of cosines says, given a triangle, let's say here's my triangle, and let's say we have x, let this side be 9, this side be 10, and let's say this is 47. And I don't know the other two angles, so this is a theta and this is a phi. Well, if I try to do law of cosines to try to find, law of sines, I'm sorry, I'd say, okay, well, x over sine 47, and then I need another full set of information. Well, here's side length 9, but I don't know his angle, and here's the 10, and I don't know his angle. So I don't have a full set of information. So I'm stuck. I cannot use law of sines. That's when law of cosines is useful. Law of cosines says, for a generalized triangle, let's call this A, and this is alpha. Let's call this B, C, beta, and gamma. A squared is equal to b squared. Oh, I guess I did capital. Sorry. b squared plus c squared minus 2ab cosine, I'm sorry, let me start that over, forgive me. A squared equals b squared plus c squared minus 2bc cosine alpha. Notice if we got rid of this part in the little square brackets I just wrote, then it looks a lot like Pythagorean theorem. And in fact, that's what the law of cosines is. Law of cosines is the Pythagorean theorem when you have a 90-degree angle. When you don't, then this extra piece comes into play. So, this is exactly what we have here. We have no 90-degree angle that we're aware of, so we need the extra piece, but this is the equation. In order to use it, what do you need? Well, first of all, if you're looking for a side length A, you need the other two sides. Okay, I'm looking for X. I have 9 and I have 10. Good, so I have the other two sides B and C. But you also need the angle associated with A. So that's this alpha. Angle with the A is the alpha. Here, the X, I know the 47. Perfect, I can use it. So let me go ahead and plug the numbers in. A squared, or for us, it's X squared, equals B squared, so 9 squared, plus C squared, that's 10 squared, minus 2 times 9 times 10 times the cosine of 47. Now, when you plug all this into your calculator, you get 58.24. However, remember, that's x squared. We don't want x squared, we just want x. So we have to take the square root, and we get x then is 7.63. That's how law of cosines works. Law of sines, you have an angle and a side, and a full angle and a side. So if you don't know the side, then you need his angle, and then any other full set of side and angle. For law of cosines, if you're looking for a side, let's say, you need the other two sides first, and you need his angle. But no matter what, given a triangle, you can either use law of cosines or law of sines. You must be given enough information to use one of the two. This is the equation for law of cosines, and this is the equation for law of sines. You'll find law of sines tends to pop up a lot more frequently, and so you get a lot more used to it. But law of cosines really isn't that bad, but it comes up more rarely. It's a little harder to remember the equation, but once you have the equation, plugging in the numbers is no big deal. Now with that, any triangle that we may come up with in our class, you should be able to solve. And it's going to be very important, you will see, especially at the beginning, when we're going to be given problems, a tugboat is, or two boats are towing a barge, and they're towing at these two different angles, and you want to know what must be the velocity of the two towing boats such that the barge moves completely horizontally. Well, the angles associated with the two tow boats may not be 90-degree angles. And so you may have to use the law of cosines or the law of sines to get what you need. Towards the end of the semester, it won't be as prevalent. It mostly comes up towards the beginning. But these are the only two things, the law of sines and law of cosines, that we have to add to our normal SOHCAHTOA right triangle stuff. You'll have a good amount of practice problems to check out. And so you'll become comfortable enough with it. As always, let me know if you have any questions. Look out for the practice problems on trigonometry. They should be posted fairly soon, and the solutions will come a little bit thereafter. See you next time.